Hi everyone, my name is Yeming. Today I am talk about my ADFT coursework. Let's start. Hi everyone, my name is Yeming. Today I am talk about my ADFT coursework. Let's start. Yeah, you can see I will follow the text 1, text 2, text 3, and text 4. The first one is text 1, time series analysis. I chose the KO stock to analyze. Next, we can see the visualization and check the stationarity. We can see the trend is rising and the volatility is rapidly light between the 2019 to the 2020. And then we check the ADF test. In this picture, we can see the p-value is very slow, very small, and we can say it is stable. And then we split the chain and test and model selection. I definite a function to choose the P and Q and get the best model is this one. It has the smallest BIC. And we plug the training set pictures in the window. Yeah, we can see it's very smooth thing and not sensitive enough. Let's look predict the test set and evaluate the model. Yeah, you can see these two pictures. It also significant fluctuations in data and insensitive access to chains. So we choose the model optimization, use the rolling forecast methods. Yeah, you can see this picture. It's the KO return prediction with the rolling forecast. In the window, we can see it's the better capture of the data chains and capture of the short-term fluctuations to be improved. And then we forecast the volatility. Yeah, it's the same step. We can see the overall upward change and higher volatility. And then the same step, we split the chain and test and select the model and get the best model. P is 2, Q is 3. Yeah, in this picture, you can see the distinct peak and effectively capture higher volatility and smoothing of the data. Yeah, it's a good sensitivity. And then predict the test set and evaluate. Yeah, it's a higher true volatility and the predict volatility is smoother. So we use the optimization with the rolling forecast methods. Yeah, we can see the volatility is better captured in this period and positive overall trend performance. But maybe we can consider complex models. Yeah. Okay, in test 2, we go to the efficient frontier. Yeah, in test 2, we choose the historical data as the source data for this session because the long periods of historical data can reduce the sensitivity of short-term. And in order to achieve the balance and quality of the data, the last 5 years of the 20 years of data are chosen to be intercepted for analysis. Yeah, and we constructing equal weight portfolios. Yeah, you can see this picture. The continuing upward trend and strong investment management and risk tolerance. Yeah, but I think we can optimizing the investment portfolio. So next time we calculate the graph the average return and risk of each asset. Yeah, you can see the JPN and MSFT has a high risk and high yield, but this two is a low risk and low return. And then we calculate the return and see the covariance, the measures of the asset. Yeah, these two are more volatile and less volatile in KO and PG. Next, we use the Monte Carlo simulation. to calculate Shakespeare. And then we choose the max Shakespeare portfolio. This point, you can see the Alex prefers tangents combinations is a highest shapes ratio and optimal points of the return. And we check the box rigs. Aversion factor A is 1. Yeah, you can see U is the investor utility. E is the expected return of the investment, and sigma is the variance of the investment. The last A is the risk aversion. Risk aversion coefficients. Yeah, we can see the weight. I think maybe it's too small, but only one is big, so I think it's not a better choice. So we choose the Alex, and we plotting the portfolio. Yeah, you can see the overtrend upwards, outperformance equal weight portfolios and SP 500 in terms of return and risk. Next, we go to the tax 3, PCA. So what is the PCA? I think it is a range of data projected to a new orthogonal coordinate system. And why is PCA? Because it reduces the dimensionality of the data. And we're plotting the correlation matrix. Yeah, you can see the lighter color is closer to 1 and the darker color is closer to 0. And then we fit to the PCA. Yeah, you can see. We divide the training set and test set, and then training the model with PCA point feed. And yeah, you can see this picture. We can see the most important factors is blend about 40% of the variation in daily returns. And first vector explain first 10 factor explain about 17% of the variance. Yeah, we can follow these 3 steps and get the portfolio. The 0 portfolio is the best portfolio. Yeah, and we drop the these 3 pictures. It is also higher than equal weight portfolio. And we check the related industrial comparisons. We can see it is the same conclusion. So I think it is the best way to use PCA. And the last is the tax 4, HRP. First, we make the tree clustering diagram. Use this step, and then we get this picture. Yeah, it's a higher similar of orange clustering, and it's generally similar of the green clustering, and then it's less similar in the red clustering. And then we can use the quasi-diagonalization and recursive B-sections. And then we get this picture. It is the portfolio way for each asset classification and achieve the effective risk diversification. Yeah, it's previously. And then we plotting out of sample forecasting and calculate their shapes ratio. Yeah, we can see the volatility is very significant decline in portfolio returns in early 2020. And the HRP portfolio's returns begin to gradually resume rising in late 2020. And then we can see the these shapes ratios. We can see the portfolio is capable of positive returns at a certain level of risk. So yeah, I think it's the very good portfolio. Okay, that's my presentation. Thank you.